All right. Good evening, everybody. So this picture describes best what kind of challenges I'm dealing with on a daily basis. And I believe I'm not the only one. But if you are lucky enough to use only one tool or service from each square, yes, please reach out to me. I'll buy you a drink. Like that was not enough, welcome to the landscape of serverless. Invented by AWS and joined by all other major providers like Microsoft Azure and Google Cloud, serverless is quickly becoming a parallel universe. So please excuse my honesty, but this feels like too much to keep up with, right? My name is Eugene. I'm the Chief Technology Officer of HashiCorp Group. We are a cloud-native automation company, born in the cloud about the same time when AWS Lambda was launched preview. So these are my credentials. And today, I would like to discuss about how we felt overwhelmed by these constantly evolving services and tools, and what we did in order to keep up with the latest emerging solutions that are compatible with legacy as well as cutting-edge technologies. The devil is in details. We strive to make IT simpler. Yeah, right. Well, I really hope you're laughing, otherwise my humor sucks, and I would be in a really awkward situation. Nevertheless, a smart guy once said, when something is important enough, you do it even if the odds are not in your favor. History shows that this guy was right. So after a short description of the problem and a short explanation into the way we think about this problem, I'll dive into Terraform for serverless. Next, let's make sure that we have the same understanding of the following three concepts: IT as a service, DevOps, and overall scope and boundaries. First, IT as a service spectrum spreads across on-premises, colocation, hosting, infrastructure as a service, platform as a service, and software as a service. As you can see, services are more or less the same in every category. But the difference is whether the customer is managing these services or not. Now, speaking of serverless, I have seen several definitions out there, but my favorite one is this tweet by Netflix former chief architect, nowadays vice president at AWS, Adrian Cockcroft. So he says, if your platform as a service can efficiently start instances in 20 milliseconds that run for half a second, then go ahead and call it serverless. Therefore, in serverless universe, we generally assume and agree among us that platform as a service and software as a service are in scope. Everything else is out of scope. Second, DevOps spectrum includes all development operations that we as engineers must go through in order to manage our IT needs end-to-end. Therefore, agile development, continuous integration, continuous delivery, and continuous deployment are part of DevOps and definitely not optional or out of scope. And third, if we go back to DevOps landscape, mark deployment services and tools as A, configuration management and provisioning as B, orchestration and scheduling as C, Terraform is B, but Terraform for serverless is a combination of A plus B plus C. And there we go. This is the core of our presentation today. So thank you for your patience so far. Now, we are ready to talk about best practices and lessons learned from using Terraform for serverless. So best practice number 1, adopt microservices architecture. This might sound trivial to many of you, but I still come across engineers who don't apply this concept in practice. Heads up disclosure, I will provide examples for each best practice. To be clear though, these examples are not wrong, but rather an indication that something can be done better. So in case of microservices architecture, instead of putting all of your resources for a service in one Terraform configuration file, break it down into smaller pieces or components, aim for one-to-one relationship between serverless resources and Terraform configuration files, like shown in the example above. After you break down into microservices, you can use Terraform built-in functionality to pass variables between resources. This built-in feature is called Terraform remote state. So if you have 2 different services that need to reference to the same variable, instead of hard-coding it in 2 different configuration files, define it in, let's say, service 1, enable Terraform backend, like we do it in this example via S3, expose it in output, and reference it in service 2 using data Terraform remote state. Third best practice, avoid using local provisioner or external data to execute external scripts. In our experience, it was extremely difficult to identify issues when something goes wrong. In the example above, data external will trigger the execution of build.js node script every time Lambda function resource is created or updated. Fun fact, we as a team established an internal rule to avoid this kind of functionality. Instead, we use Terraform orchestration tools like TerraGrant or Atlantis, or TerraHub, which is our own homegrown orchestration and automation tool. When we developed serverless applications, we ended up with a lot of Terraform components. Unfortunately, automated Terraform workflows are not built into this open source tool. Either you do it by yourself, use one of the previously mentioned orchestration tools, or switch to use Terraform Enterprise. To be factually correct, I must mention that Terraform has a built-in option called parallelism, but it doesn't work across different Terraform components. We ended up adding this feature into TerraHub CLI, and by the way, this is one of the most used commands in this tool. Next, very often, we don't need to run automated Terraform workflows for all the Terraform components. So instead of specifying a static list of components, we use Git Diff to dynamically see what changed between commits or in a specific pull request and execute automated workflow on the map of components that have been changed. Like in the example above, instead of running automation for 9 components in my repository, we used Git Diff and reduce the list down to only 2 components. If you ask me, this is a very nice optimization of almost 80%, right? One way to separate environments is to have separate code base for each environment. We don't do that. Instead, we use Terraform Workspace to logically separate environments. Like in this example, instead of keeping 4 different versions of pretty much the same configs of our dev environment and test environment and stage and prod, we use default Terraform Workspace as our de facto dev environment, and values or variables that change for a specific environment, test, stage, prod, we store them in the workspace folder. So when using Terraform orchestration tools like Terra Hub CLI, switching between environments is as easy as adding --env option in the command line. Another best practice is built around Terraform variable precedence. For example, if you have some variables used across different Terraform workspaces, instead of storing the same values across different TF-var files, right? We store everything in default TF-var file corresponding to the default Terraform workspace. And only environment-specific values that are different from the default Terraform workspace, we add them into separate TF-var file. When running Terraform commands, like Terraform plan or Terraform apply, default TF-var file comes first, and specific TF-var file comes second. So please follow this link to learn more about variable precedence. And finally, get used to a lot of Terraform, or don't. As you can see in the example above, we have almost 34,000 lines of code for around 100 Terraform components. But when we switch to YAML-based configuration, YAML-based version using Terra Hub CLI, we ended up with a little over 22,000 lines of code. That's over 30% reduction of the original Terraform code base. And we still believe we can reduce it by almost 10,000 lines of code. So another benefit of using Terra Hub CLI is that we seamlessly transform YAML into HCL and the other way around. So to summarize, today I have covered only 8 best practices. I'm pretty sure there are much more. All lessons that we have learned while working with this Terraform for Serverless. Actually, let me step back. We talked about adopting Terraform Microservices Architecture, pass variables, resources between resources using Terraform node state, avoid code build using local provisioner or external data, execute in parallel your automated Terraform workflows, optimize automated Terraform workflows with Git Diff, logically separate environments using Terraform workspace, override specific values using variable precedence, and get comfortable to a lot of Terraform. So all of the lessons that we have learned while working with Terraform for Serverless, we have included them into this open source tool for Terraform automation and orchestration called Terra Hub CLI. If you like this project, please show some support and leave us a star on GitHub. Now, let me check time. So I still have a little bit less than 15 minutes. Let's try to make a demo. So I have, all right, I have here on the left Jenkins server that we are using in order to deploy automatically some of our projects. And here you can see what's important is that at the end it executes terhub run command. Right? I will save this one. Okay, something. All right, because it uses SSO, it was outdated, the connection. Okay, so I save it over here, and I want to make sure that this is connecting. All right. So let me double check why this is not loading. All right, let me quickly. Not sure if it's my connection or connection to the service. Let me just log out and try to log in again. Come on. I don't know what's going on with my connection. Okay. All right. Now it's back. Sorry about this delay. So let me start this execution of my project. It actually will deploy out of these 100 Terraform components. I'm deploying right now only, I think, 7 or 9. All right. So as this execution starts, you can see terhub run. So now it's supposed to show in the right screen in my UI. It's supposed to show that it starts a new execution, and it shows me real time what's actually happening in my project. Okay, anytime now. Yes, there it is. Okay, so the idea of the UI that we put it on top of our open source project Terahub CLI is to show what's happening in real time, to show these automated workflows that get executed. And part of the workflow is the underneath Terraform command that gets executed for each of the components that we're using for our project. Right? And as you can see, the components that I have right now, they are Lambda, GitHub, auth create, Lambda, GitHub, repo retrieve, and so on. So I have several components. As far as I remember, I think there are 7. And my automated workflow is Terraform init, which initializes all the Terraform configuration and plugins and so on. And then it goes and executes Terraform workspace. So if I am using a development environment, it will be the default workspace. If I'm using a testing environment, it will be a test workspace, and so on. then Terraform plan is to actually analyze and show the plan. And we, since we have, like every Terraform automation and orchestration tool, we have hooks before the command gets executed and after the command gets executed. We are using this hook to analyze the plan and to provide some testing capabilities if a plan doesn't meet the requirements of our environment or something, then we stop automated execution. Then Terraform apply, which will actually execute the changes to my cloud resources. Right? As you can see, there is also a Terraform destroy. This is not a default feature. It's not enabled by default. But for development environments, for example, from time to time, I just don't need those resources to be created. I need, as soon as they're created, I'm OK for them to be deleted or destroyed. So I have also the capability to specify to destroy at the end of my workflow, automated workflow. OK? So as you can see in the left, my Jenkins build finished successfully. And in the right, I have everything is green. My build is successful. And I have here these zeros, ones, and zeros, which basically shows me how many resources been created, how many resources been changed, and how many resources been deleted, removed. All right. So that was my demo for today. I guess I'm ready to take any questions if there are any questions from the audience.
Doesn't appear to be any questions. If anyone comes up with any questions, please just type them into the chat or the Q&A.
Perfect. Thank you very much.